the way down to what's happening directly here in North America. And then we'll wrap things up by just talking about some additional support that we can offer to designers as you guys are responding to the climate industry or emergency as well. So to set the stage, I think as we think about the climate emergency, one thing that gets talked about in a general sense is how we can move towards a circular economy. And steel as a product is actually an inherent component of its own circular economy. It's a product that can start from extraction and then quickly move into consumption and then regeneration. And so what you see pictured here summarizes on a very large scale what the circular economy can look like. And I'm just going to walk through some of the ways that steel contributes to that. So first, from the recycling standpoint, steel is recycled at a rate of about 650 million tons on an annual basis. And then when it comes to reduction in the context of the circular economy, steel is a big contributor to that. With steel, we're able to not only make new steel from old steel, but we're also continually inventing new grades and therefore ensuring the reduction of the amount of material that needs to be used. Third, steel enables flexibility. We see this flexibility as inherent in the built environment, as steel permits very long spans and enables us to use buildings in different ways than they might have been originally designed for. And then finally, if we engage in the careful deconstruction of steel systems, we're easily able to reuse steel without even sending it back to our mills for regeneration. So this is kind of the starting point of where steel can contribute to decarbonization of the built environment. But if we hone in a bit more on recycling and reduction, we'll get to more of the meat of what we're talking about today. So talking about recycling, in terms of recycling, this image here is something that we borrowed from the World Steel Association, and it summarizes the relative service life of different steel products. My apologies. The biggest takeaway from it for you is to take note that a steel product can have a wildly varying use life, coming from just a couple of months for a steel can to decades for a steel building. On average, the life of steel scrap is considered to be about 40 years. That means that the scrap that we're using today is based on steel that was originally melted back in the 1980s. And as this graph shows, the world does not yet have a sufficient supply of scrap material to meet our steel demand. Therefore, we must continually generate new steel, and steel makers are focused on doing this in ways that will address climate concerns. So when we're talking about the different types of steel making, I think it's important to emphasize a couple of bits of terminology that you're going to be hearing throughout today's conversation. First, what you see pictured here are a collection of steel mills around the world. And these steel mills we've divided into two categories. The first category is steel mills that rely on primary source steel making and steel mills that rely on secondary source steel making. If we dive into what the primary source steelmaking process looks like, you can see it just pictured schematically here. In what may be recognized as the most traditional method, primary source steelmaking occurs in a blast furnace where iron ore is converted or reduced into molten iron using energy emitters such as coal. The molten iron becomes feedstock for a basic oxygen furnace where additional chemical and thermodynamic processes convert it into molten steel. An alternative method of primary source steelmaking occurs in an electric arc furnace, as pictured here on the right. This is where we take direct reduced iron, which are pellets of iron ore that have been reduced to iron in their solid state, as opposed to the molten state that was talked about with the blast furnace technology. And then we can convert that DRI material into molten steel. The carbon intensity of these steelmaking methods varies from 2,200 kg per metric tons for the blast furnace route to 1,300 kg per metric ton for the electric arc furnace route. Therefore, as the world continues to demand and produce primary source steel, the installation of DRI-fed electric arc furnaces is an off-use step towards the decarbonization of the industry. Now, moving on to the secondary source production process. Forgive me, I have a little bit of a lag here. So looking at the secondary source production process, this is where we use scrap steel to feed an electric arc furnace in order to make our molten steel. And the feedstock for this can be up to 100% scrap, or as I described previously, it can be a combination of DRI and scrap. This steel making route can present a carbon intensity as low as 300 kg per metric tons. And that typically happens when you're using 100% scrap and 100% renewable energy. And actually what I have pictured here on the right is a photograph of an electric arc furnace mill at one of ArcelorMittal's mills in Europe, where we can do just that. We can produce material using 100% scrap and 100% renewable energy with an extremely low carbon intensity on the material. So now that we've gone through the steelmaking processes, there's just a little bit more terminology that I want to introduce you guys to before I turn the floor over to Capucine. And first and foremost, and apologies, I'm having a lag again here. First and foremost, it's talking about mill types and the construction products that come from those mills. So when we're talking about mill types, you'll often hear terms of flat and long product mills to represent the two primary types of mills. Now, that is not exclusively related to one sort of production route. So I want to separate those terms from one another. But flat mills and long mills are kind of the category of the product of material that you might be able to use. And in terms of what's available for the construction industry, flat mills can produce plate product that you guys might be using already to make connections in your buildings, or flat coil products can be converted into the steel decking that's used on projects, joist products, light gauge steel framing, and various architectural elements. Long mills, on the other hand, are also responsible for a diverse range of products, and that includes wide flange sections, miscellaneous shapes such as angles and channels, sheet piling, and rebar, just to name a few. It's important to recognize these categories of production because even though there may be a steel mill located down the street from your project, it might not be a steel mill where you're able to obtain the clip angles for your connections. And just to put that in a little bit of perspective for you, in North America, there are 140 steel mill locations. And of that 140, only 70% are actually equipped to make products for the heavy construction industry. These mills are further divided into 40% being rebar mills, 35% being hot strip mills where steel coils are made, 16% being plate mills where we're making thicker materials such as the column base plates that you might be using on projects. And then only 9% of those mills are wide flange product mills. And actually, as a structural designer in my past life, one particular bit of information that I think is interesting to note is that when it comes to wide flange production, there are only a handful of mills in the world that can produce a wide flange exceeding 300 pounds per foot. And only one of those mills is located in North America. Therefore, for you guys as designers, it might also be helpful to see this network of ports that's located across North America, where unique products such as extremely heavy wide flange sections are regularly being imported into North America for use on projects. So with this, I'm going to turn things over to Capucine. And before that, since she's going to be talking a lot about what the steel industry is doing to move forward, I just want to reference this quote that comes from Our Common Future. And it's that sustainable development is not a fixed state of harmony, but rather a process of change in which the exploitation of resources, the direction of investments, the orientation of technological development, and institutional change are made consistent with future as well as present needs. And so as Capucine is walking us through what's happening in the steel industry, I think you'll see how we're contributing to that sustainable future. Thank you, Capucine.
Thank you, Shelley. So now that Shelley gave you an overview about the steel manufacturing process, we will talk more about the current footprint and as well the breakthrough technologies to decrease the CO2 emission in the steel industry and to reach at the end net zero. On this slide, you can compare the two main routes that Shelley has explained. You can see the energy consumption that is needed for both routes. And on the right, you can notice the quantity of CO2 emission that is needed per ton of steel. Just to clarify, because we will talk about scope 1 and scope 2 in the presentation. Scope 1 is our direct emission and scope 2 is indirect emission coming from purchase energy. So when you compare the two routes, you will notice that the energy needed and resulting greenhouse gas emission to remelt carbon steel from scrap is about a quarter of what is needed to make steel from iron ore, which is quite a significant difference. However, as Shelley explained as well, due to the limited scrap availability, the transition to low carbon requires a transformation in the way we manufacture iron and steel. And this is really where we need to focus our energy to decarbonize the full steel industry. To do that, the steel industry is working on different breakthrough technologies. The slide is not coming. I hope it's okay. Here we go. The steel industry is working on different breakthrough technologies. This slide is summarizing a couple of them. This is not all of them, and we will need to combine different breakthrough technology together in order to reach net zero in the future. One of them is the carbon. So if you are using carbon as a reductant, we can capture carbon from the process gases and utilize it to make chemicals for a variety of application. We can as well use sustainable biomass as a substitute to the fossil fuel. As well, we can capture the carbon, transport it, and store it. Another alternative is to use hydrogen. As you can see on the first equation, currently iron is reduced from iron ore using fossil resources. And the waste gas coming from this first equation is CO2. So alternatively, if we are using hydrogen in place of carbon in the reduction, you can notice that the waste gas produced is water. And so we are meeting use iron with a limited emission of CO2 with this technology. The third one is electrolysis. Electrolysis is a technique using direct electric current to separate chemical compounds. So the iron ore is dissolved in a solvent, and thanks to the electricity, it will separate the iron and oxygen. And if you are using a carbon-free electricity, this technology will enable to produce iron with a low carbon emission. So those are breakthrough technology coming from the steel industry. We are working as well as ArcelorMittal on those one, but we have as well other technologies that we are investigating. So let's talk about now what we are doing in ArcelorMittal. So firstly, we want to explain that we want to be transparent to the stakeholders in the industry. And we are publishing our climate action report. 3 of them have been already published since 2018. Regarding our new commitments in the climate action report number 2, released in 2021, our new 2030 target to reduce CO2 emission intensity is 25%, including scope 1 and scope 2. In Europe, it has been increased up to 35%. In order to achieve those 2030 group targets, we need to invest, and we will invest $10 billion in order to change the way we are making steel. We have a lot of research ongoing, and with a lot of investment and our facilities. One of the biggest example is the world's first full-scale zero carbon emission steel plant, which is in Sestao in Spain, and this plant will be ready by 2025. Another initiative is the X-Carb Branding. X-Carb will help us to accelerate the decarbonization of steelmaking. There is three kinds of X-Carb. The first one, the Green Steel Certificate. It's a product for product manufactured from blast furnace, basic oxygen furnace steel. And all the reduction of CO2 we will be able to decrease. Our customer will be able to take those reduction and to include them in the scope 3. And for us, it will be a help to decrease and decarbonize our blast furnace route. The second is an X-Carb recycled and renewably produced. It is a certificate for steel product made using 100% renewable electricity from solar or wind, and up to 100% scrap. As well with that certificate, there is some EPDs that has been published, and you can see the CO2 emission per ton of steel. And the last one is the X-Carb Innovation Fund. So ArcelorMittal will invest 100 million annually in the development of technologies that will accelerate the decarbonization in our steelmaking. So on this slide, you can see some example. Really, the key message is to say that we are investing as well inside but outside our companies. And so we are investing in companies developing the breakthrough technologies I was explaining you before. So what now we are doing in North America? When I'm talking about North America, it's for ArcelorMittal Dofasco in Ontario, ArcelorMittal Long Product Canada in Quebec, ArcelorMittal Mexico Flat and Long, and ArcelorMittal US Calvert. So the North American target is aligned with the new group targets, meaning 25% reduction in carbon emission by 2030. And to reach those goals, we will need to make some upgrades. A big one is in our facilities for flat products in Dofasco Hamilton. All our blast furnace will be shut down and will be replaced by a new DRI and EAF facilities. And our existing electric arc furnace will be upgraded. To do that, we are investing with the government $1.8 billion in order to save 60% of annual emission. And this will be ready by 2028. Regarding ArcelorMittal Mine Canada, there was an investment of $205 million with the government of Quebec in order to decrease our CO2 of 200,000 tons CO2 annually by 2028. What we are doing, we are expanding ArcelorMittal abilities to produce high quality DRI in order to feed the new demand for the new DRI EAF steelmaking plants in Canada and in Europe. The third one is a success story, I would say. In ArcelorMittal Long Product Canada contractor, they were the first known test of its kind in the world performed on an industrial scale. So 6.8% of natural gas was replaced with green hydrogen. So you will say, okay, it's a small amount, but it is a first step. It is showing that the technologies is available and we can do it. And we will continue to work more on this technology to replace in the future all the natural gas by green hydrogen. So you have understood that for North America, we are shutting down a blast furnace for our flat products. And so we will have a DRI EAF, so direct reduced iron and electric arc furnace technology, and to decrease the carbon emission of this technology, it will be fed in the future by green hydrogen, blue hydrogen, or bioenergy. The remaining carbon emission will be captured, transported, and stored. So I talk about the innovation in steelmaking and as well all the product availabilities. So this will enhance steel's contribution to a low carbon and circular economy, as they enable designers to leverage steel makers' technical expertise and high-strength steel, versatility, durability, and recyclability. So in ArcelorMittal, we want as well to support the designer's response to the climate emergency. To do that, we are providing tools, we are doing case studies, and we are providing technical support. So one of the examples of initiative that we launch is Stelligence. So Stelligence is a holistic approach to building design. We are analyzing the building as a whole, not the different part of the building. So really, we are investigating the building, taking into account the foundation, the structure, the facade, the mechanical units, and electricity. And we are exploring for different scenarios the benefits of steel and solution in building construction through case studies. For now, for North America, we performed case study for office building, mid-rise and high-rise residential buildings. And in those case studies, we are calculating the cost, the weight, and environmental impact and speed of construction of the different scenarios. The next slide is showing you the result of the high-rise case study. So it's a building located in Hamilton and which has 22 stories. You can see on the first graphic that we are comparing, so the same building. The first bar is the concrete. So the building has been designed with cast in place concrete. And the alternative is the same building with same functionality, but using steel, including high strength steel, structural floor system as an alternative to concrete. And you can see that we can obtain 38% reduction of mass, which will translate in their environmental impact. So we perform a life cycle assessment to evaluate the CO2 emission per design scenarios. And you can see that we obtain 21% reduction CO2 using steel as alternative to concrete. So what is important to know, it's really, as a designer, it is important to choose the right material at the right place, try to optimize the quantities because it will have an impact on the result regarding the CO2 emission of your design. So this is a generic case study. I will let the floor to Shelley, who can present you a real project in which there is concrete results.
Thank you, Capucine. Oh, it looks like I am in control again. So just to wrap things up, I'm going to go very briefly over a case study of a project that has been going on for a long time up in Toronto. And I'm not going to get deep into the history of this project, but folks in Toronto might be familiar with the Bay Adelaide Center project. And I know Intuitive, our host for today, is particularly familiar with this project. This project is an interesting example, though, of using cutting edge technologies in order to increase the efficiency of the design, which obviously has cost and carbon intensity implications on the project. So this project utilized high strength steel in the form of ASTM A913 grades 65 for the first level of design, and then grade 70 and grade 80 in the ultimate tower, the north tower that was recently completed. And in using these high strength steels, it enabled the project to see a weight savings across these buildings of 9% of the total weight of the buildings. That is significant because high strength steels were primarily incorporated for the column elements in these buildings. And obviously that can have a really strong impact on the carbon intensity of your design. And it also can have have cost implications and construction implications as well, which all come into the sustainability bottom line. So beyond that, you know, Capucine and myself, we're here and available as technical experts, both of us with backgrounds as structural engineers. And we're able to not only support you on the designs that you're working on, but help walk you through some of the resources that are available in order for you to bring more efficiency to your design in terms of carbon intensity or in terms of structural efficiencies and cost efficiencies. So we're going to leave you here with these links. They'll be in the final presentation that you guys get a hold of. And they're just a selection of some of the resources that are at your fingertips in order to help with the decarbonization effort. So with that, if there are any additional questions, you can obviously contact us, and then I'll turn it over to Natasha, who will let us know if we're going to do Q&A now or at the end of the conversation.
Thank you, Shelley and Capucine. So we'll do Q&A at the end of the session. So I'm going to call up now Dave and have him do the presentation for Nucor. Just give me a moment. Okay. Okay, so David is Manager of Environmental Sustainability for Nucor Corporation. He has worked in the steel industry for 24 years. In his role, Dave works to further Nucor's leadership as one of the cleanest, most sustainable steelmakers in the world. Dave joined Nucor in August of 2020 as Manager of Environmental Affairs and accepted his current position of Manager of Environmental Sustainability in January 2021. Welcome, Dave.
Hey, thanks, Natasha. Glad to be with everyone this afternoon. Probably should have picked a different skyline than New York City since it's a Toronto thing, but oh well. Just noticed that. Flying solo today. If you could, flip to the next slide. One more from there. Just a little background on on Nucor. A lot of people don't really know the Nucor story. Of course, we're the largest steel manufacturer in in the United States. And interesting how we got there. Our CEO back in the late 60s, a guy named Kenny Iverson, really a true leader in the industry. We were not making steel back then. We're really operating a Volcraft, right? Which still operates today, making joist and deck. And business conditions were just such that we're having a hard time, getting steel at competitive prices. So, he had the idea, well, let's look at this new thing called the electric arc furnace, which really hadn't gotten much traction, maybe no traction at all here in the States at the time. So we, built our first steel mill in Darlington, South Carolina, to supply that substrate to the joist and deck business, and then built another one, and now all of a sudden, I think we have, 25, 26 steel mills either in operation or being built. Actually in the process of commissioning or building 5 new steel mills as we sit here today, or at least doubling capacity of a couple. I don't think, Ken Iverson had a thought that as a result of that decision, be combating climate change, but his thought process was in the right place. Let's find a way to make steel using as little energy as possible, and was successful in doing that. Right, the two main drivers are scrap and electricity in terms of making steel with an electric arc furnace, and as a result of that, we have this really natural competitive advantage when it comes to making steel with a low carbon footprint. And you can see, we've got bar mills all over the States, 5 sheet mills, building another one, a couple of beam mills, a couple of plate mills, and then lots of products divisions located all around, whether it's a Harris rebar facility, a Volcraft facility, Skyline, insulated metal panels, you name it. And we are the largest steel producer in the United States, recycling somewhere north of 28 million tons of scrap each year, over I think 32,000 teammates now with several acquisitions that have someone that just a good size one just closed today. So, you know, very, very excited to be here, tell a little bit more of Nucor story. And of course, a lot of steel companies have and do continue to, you know, mimic what Nucor did back in the 60s, either by you know, building new electric arc furnaces or replacing blast furnaces and BOFs, electric arc furnaces. Likely no other transition in the steel industry has meant more to reducing greenhouse gases associated with steel than, you know, Nucor really bringing the EAF truly to you know, to market here in the States. So you flip to the next slide there. This is really where we, you know, where Nucor stands. This is, you know, quite simply a scope 1 and scope 2 emission intensity, the amount of CO2 produced per ton of steel. You know, we're there at a, you know, at a 0.43, I think was explained earlier. Scope 1 emissions are direct emissions. Scope 2 emissions are emissions created from electricity that we purchase. And you know, sitting there at a 0.43 versus the global average, the difference is pretty stark. And as we start to see more transition to EAFs, you know, that average will obviously start to come down. And here at Nucor, you know, if we did nothing, if we just stayed where we are, you know, here in 2022, if the whole steel industry was at that same point, we would be on pace to meet this below 2-degree target, you know, all the way out in 2042. So kind of look at it like we're, you know, about 20 years ahead of schedule where the whole steel industry needs to be. And I'm going to be talking here a little bit later in the presentation of things we have cooking here to try to remain, you know, the tip of the spear as it relates to greenhouse gas intensity and emissions associated with steel production. So if you'll flip it, Natasha. Another, as you would expect with a low greenhouse gas footprint, you see a low energy intensity as well. So, you know, when it comes to, you know, what the designers need to know about designing and specifying materials, you are absolutely going to get the lowest carbon footprint available with steel made by EAFs. You know, and this is just a testament to that. You saw the greenhouse gas data before. You see the energy intensity data here. You know, we're sitting at, again, energy intensity. This is all the electricity, all the natural gas, all the you know, any type of fuel that's used per ton of steel made, sending roughly 25% of the global average. Obviously, a lot of that is just tied to being an EAF producer, even though we're very efficient at doing it. You can see the recycled content there. Global average of 35% versus a 75% average. So, you know, our bar mills are going to run, you know, more like a 98, 99% recycle rate. A sheet mill, especially sheet made to make, you know, higher quality product, it's going to be closer to a 50 or 60% recycled content. Reason for that being, you know, in your melt, the more scrap you use, the more copper content you're going to see in the heat. So, you know, if you're making a high quality product, to avoid some sort of cracking or quality issue, you really need to start to feed in virgin iron units like a DRI or like pig iron. And we have 2 DRI facilities, one in Louisiana, one in Trinidad, to you know, to help support that effort. I'll talk about that and some of the GHG reduction activities we have planned here in a second. If you go ahead and flip it, Natasha, 2 more slides. These are the targets that we've set. We set them last year, aggressive. I'll skip to number 2 because that's really the meat of the discussion. You know, we're committed to an additional 35% combined reduction in our scope 1, scope 2 intensity by 2030. You know, well on our way to hit that, and we use 2015 as the baseline. That's when the you know, the Paris Agreement was ultimately adopted. So. And another thing we are focused on are scope 3 emissions. You know, our scope 3 emissions for a bar mill, for instance, are very, very low because the recycled content is so high, and it's going to be higher on sheet mills. So, you know, it takes your intensity for a sheet mill somewhere from about a 0.43 to right about a 1, somewhere between a 0.9 and a 1. But we're transparent about those. You know, we report our Scope 3 emissions and sustainability reports. We report it, and you'll obviously see it in an environmental product declaration for an EPD. And again, I'll talk a little bit later about what's cooking on trying to reduce GHGs in our supply chain. If we'll go ahead and flip. So these are the four main buckets that we're focused on. Renewable energy, of course, is a big piece of the puzzle. You know, being electric arc furnace, you're going to see the grid, you know, naturally continue to green over time, and you know we get that benefit without having to do anything. But the other items that we're working on the renewable energy front certainly are PPAs, VPPAs. I'll talk a little bit about the virtual power purchase agreements we've entered into. You know, we essentially commit to buying power from a solar farm or a wind farm at a certain price, you know, for 2 to 10, 12, 15 years. The developers be able to take that commitment, you know, using Nucor's credits, go to the bank and say, okay, we've got a buyer for this renewable electricity for the next 12 years. You know, give us the money so we can go out and build our thing, right? And that's what we've seen. You know, with the VPPAs we've entered into so far, and starting to deliver very well for us, and supporting the net zero product that we have currently. So that's really bucket one. Bucket two, more of a energy efficiency type push. You know, we have different projects to really try to manage the layer of slag foam, right, that we have on our EAF bath, to make sure that we're using as little electricity or little energy as possible to go ahead and make that steel. Obviously, our team is financially incentivized to do that. Other items to sort of consider on the efficiency front are Hickman, Arkansas galv line. You know, it's the first to produce this advanced high strength steel with the EAF. Right, it's really to support kind of a light weighting approach for automobiles, where you get that strength for the steel without all the weight. So there's an inherent carbon advantage to that as well. Bucket three, we talk about the pioneering circular steels. As I mentioned, Kenny Iverson in the 60s decides to go ahead and put in through the electric arc furnaces, and now we're the largest recycler in the country, and we continue to look for ways to up that. And it's important right now. I mean, raw materials are expensive. With the terrible events going on in Ukraine and Russia right now, we are no longer purchasing raw materials from that area of the world. We're finding more sustainable ways to do it, whether it's with low copper shred, sustainably made pig iron, just being smarter about the raw materials that we're using to achieve our melting goals and our melting strategies. And as a result of that, we're going to see our total carbon footprint take a step downward, and we're certainly excited about it. The fourth bucket, which I'll just touch on briefly, we are looking at carbon sequestration. It's something that doesn't make a lot of sense necessarily at an electric arc furnace, because that CO2 is only about 2% of the off-gas concentration. We do have a partnership with DOE at our Gallatin, Kentucky facility to look at how to separate that waste stream or that CO2 from the off-gas. Where it's going to make a lot of sense for us is one of our DRI plants, for instance, especially one where it has a very high concentration of CO2. Louisiana, for instance, has about a 98% CO2 off-gas stream that makes up about 65% of the CO2 down there for DRI. So sequestration opportunity there would make it I believe it would be the lowest carbon DRI available in the world currently. That's not just being done on some sort of minor scale. There are, every one of these carbon activities, whether it's a biomass replacement of injection carbon, or whether it's carbon sequestration, there's always going to be people on both sides of that on every issue, it seems. And the way I like to talk about sequestration is, that the carbon is already locked up in the geology. We're able to still use those fossil fuels and then take that carbon and lock it back in the geology. So that's the general concept. If you could go ahead and flip to the next slide. And scope 3 emissions for us for a steel mill is like our DRI plant and a pig iron, and it makes up a pretty good chunk of it. But sequestration, for instance, could take that 0.36 for a sheet mill and easily cut it in half. So it'd be a big move for us. You'd certainly see it not only in the greenhouse gas inventory from a corporate standpoint, but you'd see it in environmental product declaration, GWP, that you're going to use to design your building or your bridge or whatever it may be. And also, as I kind of mentioned earlier, there's some opportunity to use some renewable resources to create pig iron. You can flip, Natalie. I want to talk just a tad about Econic, and I think this gets into one of the questions. What are the challenges trying to meet requirements and bring these solutions to market? Econic was ultimately born there at the bottom bullet point in working with General Motors, supporting the automotive industry, and they of course use lots of steel from the traditional coke plant blast furnace BOF, and try to want to move as much steel as they can into the EAF lane, just because there's such a lower carbon footprint associated with EAFs. And their challenge to us is, well, how can you take that 0.43, even though it's already 75% lower than the global average, and trim that down even further? And you do it with the RECs that are generated from the VPPA investments that we've made, and that takes you down to about a 10%. And that's a tricky one, and we are having to purchase offsets to cover that last 10%. We view that as a bridging mechanism until we have projects in-house to be able to create our own offsets with some of the things I talked about earlier, whether it's carbon sequestration or another project. But Econic really is this net zero approach, where we take our our average 0.43 emission intensity down to zero, again using offsets for that last little bit of scope 1 emissions, and then renewable electricity from our VPPAs to deal with scope 2. If you can flip to the next one. More. The demand that we are seeing, really, and even though the economy certainly is having its issues here over the last month or so, this Infrastructure Investment and Jobs Act, this is just a sort of a snapshot of kind of how we see the market. The steel containing investment, according to AISI, looking at $850 billion to support this effort. Huge amount of money. Steel demands are through the roof, depending on who you want to look at. Call it SMA saying 4 to 6 million tons per 100 billion, and then ASI 5 million tons per 100 billion. Pretty equal numbers there. So the total demand over the next 5 years, looking at something like a 40 to 45 million tons of steel products. So roughly 50% of Nucor steel is used in the construction sector, and so that's 850 billion in steel containing investment. Does not include indirect steel demand. So it's an important point to make. And Tasha, if you move to the next. So what does that mean to the world? So I know we're at a building conference, but I still wanted to make sure, because this does translate to whatever you're working on. So For instance, for the EVs that we expect, the electric vehicles we expect to see on the road by 2030, we're looking at the estimates about 145 million, and that's up from a relatively small amount just a couple of years ago, maybe just 8 million cars on the road. So for every car, you need about a ton of steel. So for 145 million EVs, you got 145 million tons of steel. You make that with the EAFs, you're at 62 million greenhouse gases to support that effort, as opposed to going from a more traditional sense where you'd be at a 322 million total number. So if you're sitting there designing a building, you need to be focused on using an EAF as much as you can, because that is where you truly hit the lowest carbon content available for the steel you're using. Natasha, if you move on. Similar thing for wind energy. There's like 4,500 tons of steel associated with building one of these wind towers. It's a massive amount. So we're thinking there's probably about 7 million tied to build this 30 gigawatts of planned offshore investment. And one of our new plants that we're starting up that I mentioned earlier in Brandenburg, Kentucky, that's actually supposed to strike an arc here relatively soon, is going to be making plate to help support this market. Again, you use a EAF plate at 3 million, you have about 3 million tons of steel to support this effort, as opposed to a traditional approach would be 16 million. Next slide. So at the end of the day, sustainability is driving business decisions. We're seeing it with architects, we're seeing it with fabricators, and we are continuing to make sure we lead the pack on transparency. The first of the year in 2021, we had one EPD for one product at one division. As we see here today, we have 6 products at 39 divisions. Really have made a push to make sure that we get the environmental product declarations out there to support all of our business. But really, that's a focal point on the construction segment. Lots of folks interested in what the GWP is at all of our various facilities, and we are obviously still committed to reducing our greenhouse gas emissions by driving some of the innovation topics we talked about earlier. Next slide. Just a real snapshot of what Nucor is doing now in terms of investments coming up, and in recent history, 12 million in CapEx over the last decade right here in the United States. Nearly 6 billion more announced, and that's the nearly $2 billion sheet mill or plate mill in Brandenburg that I talked about earlier to help support offshore wind farms as a part of that. New tube mill that is going to be involved in part of the big market there is supporting these solar farms. Of course, the Arkansas galv line there with the high strength steel, first of its kind, made by EAFs, and then another 800 million for 3 micro mills located, one in Florida, one in Missouri, one in a new one just announced here in North Carolina. And the beauty of a micro mill is, most steel mills, after you cast your steel, you go through a reheat furnace prior to going through a rolling application. With a micro mill, you don't do that. You go straight from the EAF, and then slide right over to the bar mill. So there's actually no natural gas fired reheat furnace there. So you end up with a much lower carbon content for material made with micro mills than you would for a more traditional, even EAF steel mill. And then our biggest endeavor here, $2.7 billion in West Virginia to build one of the lowest GHG sheet mills in the world. So that I think that's it. I'm not sure as you flip the next slide. Yeah, that's it. I appreciate your time today and look forward to some Q&A.
Thank you, David. That was great. So I'm just now going to open up to the Q&A session. So if anyone has a question, feel free to unmute yourself and turn on your video. Otherwise, I see that there's already some questions here in the chat box. So I'll go through those. Okay, so the first question, I believe it came up during the ArcelorMittal presentation. It's how long will the flat product Dofasco Hamilton be shut down before it is up and running again in 2028?
Yeah, so this I have to clarify. We are not shutting down the mill. We will start first to build the DRI EAF, and then after when, and we will continue simultaneously the blast furnace, and when both process will be okay, we will shut down in 2028 the blast furnace at the end. So we will provide, we will continue to supply the market. It will be challenging, of course, because yeah, we are creating a new facilities and shutting down one route, but we take that challenge and we will do it like that.
Thank you. And
Thanks.
there was...
Hey, Natasha, thank you for that. Sorry to interrupt. I just wanted to make sure that you go, because I'm looking at the time. I just want to make sure you go to the last question next, which is about the specifying the products. Thanks.
Sure. So Stephanie had a question. Specification for structural steel and miscellaneous metals are performance-based. What is best practice for specifying an industry accepted % of recycled content, as well as establishing a GWP baseline and corresponding % reductions?
So I think if you don't mind, I might address this first. So, you know, I'm going to take the perspective here of not necessarily a steel producer, but more thinking about the experience that I've had as a design engineer who's also represented steel mills. And I understand what the intent is behind trying to specify more scrap content in your products that are being used on your projects, and then also trying to specify particular limitations on global warming potential. I think, though, right now where we are with the global conversation on decarbonization, we might not be at standard accepted values today. And so kind of entering into that territory in your specification procedures might actually put the project in a difficult position when it comes to procurement. So other considerations to make to promote more transparency and more advancement in the industry is really, you know, I've heard a lot of practitioners who on their projects for as many materials as is practicable, they're requiring EPDs without putting a limitation on it. And then they're starting to kind of study that internally and determine, okay, where do we want to end up as practitioners and with our practice? So at this point in time, I think kind of throwing up the signal that EPDs are important and that transparency about decarbonization practices are important might be an interesting approach to take from the specifier's perspective. And actually, your request can go beyond EPDs to be climate action report submissions or any sorts of submissions that are related to tangential reporting with respect to decarbonization practices. But that's just my perspective here. Go ahead.
Yeah, if I may, the reason I brought it up is Canada's quite progressive, and a lot of the firms that are on this call have signed on for either the SE 2050 challenge or the zero carbon standard. And in both of those, we're required to do significant reduction on major structural components. So I guess it's hard for us because we're getting pushed to mandate this and to track it in the life cycles that we do. And based off your response, I guess it's a bit concerning that maybe the industry needs to be informed that the expectation of these signing authorities that we go on to aren't really tapped into what's reasonable within the industry right now.
Well, you know, I don't mean to raise particular concerns. I don't know what exactly you're referencing that you've signed specifically, but you know, I do know, for example, in the United States, various states have been moving towards buy clean regulations. And even those types of regulations, there's a lot of debate about what the appropriate levels are to be at for the global warming potential for each, or for how you're specifying products. And, you know, I guess you also have to be really careful because the global warming potential targets, they're going to be moving as decarbonization is working its way through the production process. Like what would be kind of industry acceptable targets are going to be changing. And then also, if you look at product specific averages, you're going to be at different levels for all of that. So I think saying, you know, one value for all the steel in your project is going to be, it could lead to procurement issues in the future. So, you know, there are some resources that you could look into to see how it's being proposed with like government guidelines in other places. But I don't know that there are necessarily published standards today that are going to be the best acceptable, most appropriate for procurement for your project.
Yeah, I can piggyback on that just briefly. Actually, July 1st, Buy Clean California goes into effect, right? They've set thresholds for rebar, plate, and beam. That's one of the reasons we Nucor put EPDs together on our website. So everybody can go in there, pull them up, and plug in that GWP value to their building LCA or whatever they're doing, and come up with their number. So that's one of the reasons we did it. And we've started to see other states start to look at their own thing, perhaps think about numbers that are a little bit different, ways to calculate it. We've obviously seen some potential movement on a federal side as well. So it is the target is moving quickly, and it's somewhat difficult to keep up with. But certainly, Stephanie, if we have a spec here at Nucor, if you're interested in it, just send me an email after the fact and let me know that talks about GWP and recycled content. Happy to help you out any way we can.
Sounds great. Thank you.
Thanks, Dave. And I see that we're over time now. So if you have any other questions, I realize we didn't get to go through all of them. Feel free to either reach out to ArcelorMittal or Nucor directly, or you can direct the questions to CLF Toronto and we'll get you in contact with our panelists today. So I'd like to sincerely thank Shelley, Capucine, and David for joining us today. Both presentations were great and very informative. To everyone that's still on the call, stay tuned for an upcoming webinar on July 19th. Our last material series will be on mass timber construction. We'll be sending out the event invite in the coming week, and we highly encourage everyone to attend. So with that, thank you again to everyone, and I hope everyone has a wonderful weekend. Take care.
Thank you.
Thank you.
Thank you. Bye.
Bye-bye.
Thank you. Bye.